I want to let you know, you are going to like this method the best because it is the easiest. The reason I didn't show you this one first is that unfortunately it doesn't work all the time. So it only works if what you're dividing by is linear, meaning your divisor has just an x to the first power. There's no x squared or anything higher. If that happens, you have to use either the area model or the long division. This method works again only if you're dividing by an x to the first power. But if you are, this is by far the easiest way. So we're going to start off by doing the one we just did, except we're going to use this synthetic division model. Here's how synthetic division works. We're actually going to focus just on the coefficients, the numbers in front of all the x's. So for example, I've got 1x to the fifth, and you can't skip any powers. So there's 0x to the fourths, 9x to the thirds, then 17, x squareds, minus 3, and minus 6. So just listing the coefficients, starting with the highest, going in order down. If any are ever missing, put that 0 in. It has to be there. You're then going to set up a little line across the bottom, all right? And a little box. Now, I like to make my box just like this. So it's like a bottom and a right-hand side. In this box, you're going to put the number that makes this factor equal to 0. So if x plus 1 equals 0, then x equals negative 1. Okay, then negative 1, that's the number that goes in this box. Here's your procedure. Start by taking the first coefficient, and you just drop it right down below the line. From here on out, it's always going to be the same two steps. Step 1, multiply the number down here times the number in the box. So 1 times negative 1 is negative 1. That's what then goes under the coefficient in the next column. And add them together. 0 plus negative 1 is minus 1. And now repeat. Number at the bottom times number in the box, always times number in the box. That's positive 1 this time. That then gets written underneath the 9. We add them together. Number at the bottom times number in the box, that's negative 10. Add and repeat. 7 times negative 1, well, that's negative 7. Okay, negative 3 plus a negative 7 is a negative 10 overall. Go again. Negative 10 times negative 1, well, that's positive 10. Negative 6 plus 10 is 4. Once you get to the end of the line, you're finished. Here is what these numbers now represent. Starting at the back, this is your remainder. This is your constant, your x's, x squareds, x to the thirds, and x to the fourths. So what's our end result? Why, it is 1x to the fourth minus 1 x to the third plus 10x squared plus 7x minus 10 plus the remainder of 4 over x plus 1. And if you give it a look, that's the same thing we ended up with right here. It was a little bit quicker to go through it this way. So the takeaway, this is a method, synthetic division, that you can use anytime you're dividing by an x to the first power. Quick recap, and then we'll do another. So set up this little grid here, the coefficients of your dividend in order. If there's any missing, you have to put that 0 in. If you don't, it's going to screw up everything. That 0 has to be there if there are any missing powers. And then in the box goes whatever value for the variable makes the divisor 0. So honestly, it's worth it, making sure you take the time to write this step out so that you put the right number in the box. Let's go again. I think I would like you to, I won't talk out loud here, I'll just show my steps. You do yours at the same time, and then we'll compare things. Okay, if you haven't done yours yet, do a quick pause. Now let's interpret this answer. So now always starting from the right end and then working your way back. Don't forget this is not your constant, this is always your remainder. What you end up with is the remainder, then the constant, then the x to the first, x to the second, x to the third. So what have we got? 1x to the third plus 5x to the second minus 5x plus 6 plus the remainder of 12 over x plus 3. Okay, let's go again. Now, even with your synthetic division, you do need to be a little bit careful if there is a coefficient here in front. Here's what I mean. Let's get things set up. I'm going to save here. We'll put this number in the box in a little bit. I've got 3x squareds, 29x's, and an 8. Now, when we figure out what number goes in the box, you do it the same way. So take this factor, set it equal to 0, subtract the 2, and divide by the 3. So we're going to have a fraction in the box this time. Here's the thing, though. Synthetic division doesn't know that you started with 3x plus 2. It thinks you started with x plus 2/3. It thinks it's dividing by this. So there's an easy way to fix for that and to compensate for that. We're basically just thinking of 3x plus 2 as this, 3 times x plus 2/3. So we're simply going to do this in 2 steps. First, let's do the synthetic division like we normally would. Bring the first number down. Negative 2/3 times 3 is negative 2. 29 plus negative 2 is 27. Negative 2/3 of 27 is negative 18. 8 plus negative 18 is negative 10. Now the nice thing here is that the remainder is correct. It's going to be what it's supposed to be. Our remainder is negative 10. But I've technically only divided by this part so far. I haven't divided by the 3 yet. It's now up to us to take these two coefficients and divide them by that 3. So really, if I divide by 3, I want a 1 here. And if I divide by 3, I want a 9 here. So what do we end up with? Well, this is my remainder, my constant, and then my, x? Yeah, there it is. So what I have is 1x plus 9 with a remainder of negative 10. Now you've got a choice. When your remainder is negative, you can write plus negative 10 over 3x plus 2. You could also just write it as minus positive 10 over 3x plus 2, whichever makes you happiest. Okay, the takeaway here from this last one, the only additional thing we had to do was you set everything up like normal, but when you're finished, take the coefficients that aren't the remainder and divide them by that front 3. That's all it is. So if we had divided instead by, say, 5x plus 7 or something, you'd in the end here do a division by 5. If our original factor was 2x minus 4, then you would take everything at the end and divide by 2. So notice we didn't have to do that in the others because there was no number in front of the x. It's only when there's a coefficient in front of the x that you have that extra step of division.